Hi everyone, and welcome to this webinar brought to you by the Information Lab. Here at the Information Lab, we dedicate ourselves to helping people make sense of data using Tableau and Alteryx. You're here with Adi, bringing you the second episode in our Spatial Essentials series. In this selection of webinars, we'll be focused primarily on the application of spatial analytics and location intelligence for local government and public health. If you're looking for episode 1, click the link on the screen now to go watch it and come back here when you're ready. In this series, you'll probably notice a little overlap with our location intelligence in Tableau videos. Here though, we'll also do the equivalent work and more in Alteryx. The examples we use are skewed towards public health application. But even if that isn't your industry, do stay tuned. The fundamental principles are absolutely transferable to any organization looking to add value through their geographic data. Those fundamental principles being where things are and establishing location, how many things are where and dealing with spatial aggregation, and finally, what is close, dealing with proximity analysis. The technical specs for adding value, I'm using Tableau 2020.1 and Alteryx version 2019.4. If you look in the description box of this video, you'll see a link to a file share location where you can find all the data and the starter workbooks that I'm using here. Now that's a zip file, so remember to hit right click and extract, perhaps onto your desktop, before you start using those materials. It's going to be great practice to follow along with me, so do join in. Today, we're continuing to build on the fundamentals of where in both Tableau and Alteryx by looking first at alternative coordinate reference systems, those where the XY coordinates are not latitude and longitude. Second, we'll look at UK postcode data and how we treat that in Tableau and Alteryx. And third, how we can create a spatial filter that helps us select out only the details in particular geographic areas that we're interested in. So let's get into it. In order to deal with alternative coordinate reference systems, those geographic identifiers in our data sets that are XY fields but not latitude and longitude, we're going to leverage Tableau's new spatial functions. To address this in Alteryx, it's a little more straightforward, and I'll take you through that later in today's session. But first off, we need to understand a little bit about coordinate reference systems as a concept, where they come from, and how we can use them. Now, this is a big topic, much more detailed than what I can cover here. But if you do wish to read more, I'd highly recommend Tableau mapping guru Sarah Battersby's blog, and I've linked that in the description. It's a fantastic read. For us, and to put it simply, the Earth is a 3D object that's almost spherical. It has some lumps and bumps with high mountain ranges and deep sea trenches. But when we locate ourselves on the sphere, we use the latitude and longitude degrees. North-south from -90 to +90 degrees at the poles, and east-west from -180 to +180 degrees at the international dateline. Now, in order to represent that 3D Earth in 2D form on a flat piece of paper or on a flat screen, we need to squash down the 3D object in order to make it flat. There are an almost infinite number of ways to do this squashing, and you'll see some on the screen just now. And the selection of the squashing method really depends on the mapping purposes. If we wanted to focus on Antarctica, for example, we'd squash our 3D Earth in such a way that Antarctica is the focus, and that any distortion introduced from the squashing procedure is minimized. And this process will produce not only a different projection or different squashing method, but also a different set of identifiers that specify the way the projection really should operate and its parameters. And we can think of those identifiers as our new XY fields. And while the use of latitude and longitude is sort of standard, universally applicable system, The new coordinate reference system that we generate is different for each projection that we have, whether that's our system for Antarctica, as data school consultant Ellie Mason used in this viz, or the system for the United Kingdom. And we're going to look at how it works for the United Kingdom, so we can move along with the school location data source that we explored in the first session of this training. The UK-focused coordinate reference system is called British National Grid. As the name suggests, it's a grid-based system that helps us to identify location. The easting is the x-coordinate running west-east. The northing is the y-coordinate running south-north. For British National Grid, we read along the easting first and then up the northing. If we want to identify the red square in this example on the screen, the general location at a 1 kilometer resolution is 6450. And if we break that larger grid into smaller grids, we can call the red square 646504. That gives us a 100-meter grid square. And the more we split each grid into subsequently smaller grids of 10, the greater the spatial resolution we get, to the extent that we can have 6 figures in each of the eastings and northings field, and that is a location at a 1-meter resolution. Now, if we reflect back on the schools data set that we have, you can see here that we have 6 figures for each of the fields, eastings and northings. So it would be possible to locate the schools to a very high level of granularity. But the challenge is making Tableau understand this coordinate reference system, because its own system is not the same. Tableau natively will recognize latitude and longitude fields because it's using something called the Web Mercator projection. And we therefore need to tell Tableau that our XY fields are in a different form. And we'll also need to help Tableau understand how to convert the XY fields, the eastings and northings, into collected latitude and longitude points, which we can then natively plot. This operation, it's a really huge deal. And so we've got to say a huge thank you to the people at Tableau who've made this possible. Let's work through the details in Tableau. Now, in this example, you can see on the screen that I have my original schools dataset. We have its distribution across London. And if you look in the bottom left, you can see that I have 3,887 marks in the view. Now, to show you the reprojection operation, I'm going to use a schools dataset where I've removed all the geographic identifiers with the exception of eastings and northings. So there's got to be no cheating, no hustling, no side tricks, just reprojection. So let me go ahead and add that in. I'm going to move up to the menu bar and hit this plus icon behind this, beside the cylinder to add a new data source. It's a text file, so I'll click text file for CSV. And then I'll just navigate to my data sources. Now you can see here I have school locations. I've called this BNG only, British National Grid only. Let's open that up. And we'll just drop back into my worksheet here. I'm going to right click on Object ID. I'm going to make this discrete and then just drag it up to dimensions. Now again, as you can see in the measures, no latitude, no longitude, no generated latitude or longitude. So we're going to use Tableau's new functionality to get these objects onto a map. And the small caveat to this method is that we need our data source to be live when we perform this reprojection operation. But after we do the calculation, we can then extract. So we have to be live first, perform the calculation, then extract. Alrighty, we're all set. Now, as I just mentioned, we're going to collect the equivalent latitude and longitude values for the eastings and northings. We're going to collect those into a single field that we can plot, a spatial object. So we're here with the relatively new make point function. So let's create a new calculated field using this drop down at the top of the data pane. We'll hit create calculated field, and we're going to call this schools BNG. As I said, we want the new make point function. I started to type that in, I hit enter. You can see we get some short instructions right under that function. And if we look to the right hand side of our calculation box, we get a slightly longer explanation of what's going on. And when we want to do the reprojection operation, it's the second iteration of the make point configuration that we want. So we have make point number, number, number. If we look down, we're going to create a spatial object, yes. When we're going to construct that object from an x coordinate, an easting in our case, a y coordinate, a northing in our case, and something called an SRID, which I'll explain in just a second. First off, our x coordinate is our easting, so I begin to type that in. Y coordinate is our northing. I could start typing that in. I can also just left click and drag that into the calculation window. And the third thing, this is the magic. It's the special ingredient that tells Tableau what system the original data is in. Tableau is calling that an SRID, a spatial reference ID, and that's simply a numerical code that represents the name of our alternative coordinate reference system. In this case, we're using British National Grid, so we want the code that corresponds to British National Grid. Now, I know that to be 27700. That is always the code for British National Grid. And I know this because I've used a searchable website, which I'm going to bring up for you now, called spatialreference.org. And we can search British National Grid up here in the search bar. And the code that we want, this is the accepted projection, British National Grid, with the little prefix OSGB 1936. You can see that 27700, that's the one we want. Also notice that on this website, the code is prefixed with EPSG rather than SRID, but for our purposes, they're kind of interchangeable. So we'll drop back into Tableau again. We now have everything we need. The X coordinate with the easting, the Y coordinate with the northing, and then the SRID, the 27700. So let's complete this. We'll hit OK. And you can see straight away, Tableau has recognized that there's some geography about this field. It's given it the blue globe. And we've also had the addition of a generated latitude-longitude field. So let's see what happens when we double click. Okay, we've got a map where we had no map. So this works, this is good. Let's reflect back. Yeah, we're there. Now notice a couple of things. First off, we're plotting a single object for the full data set. Look in the bottom left, you'll see one mark, one row by one column. And we have a single mark representing the full data set until we add some granularity into the view. And with object ID from the dimensions on detail, you can see that I get the full 3,887 schools, and I can interrogate them all individually. Now this is very, very powerful. We've done this without a latitude, longitude, without any previously specified geographic role. So if you remember when I added this data set in, we had nothing. We had easting, northing, no explicit lat long, no generated fields, but we've been able to create that using Tableau and get our objects onto a map canvas. That is a beautiful thing. We've been able to do that using the new make point function, and we've reprojected the points in a calculated field that we created. In Alteryx, all of that functionality is available within a single tool in the interface, and that's the Create Points tool that you'll remember we used in the first session. So let's go back into our initial workflow and take a look. If you're following along at home, go ahead and reopen your starter flow in the participant material folder. That's called number 1, adding spatial data. And I've got that open just here. Now to recap, we have as our incoming data the same original school's location field. The school location file. In there, you remember we had latitude and longitude. They were originally called X and Y. And we used the Create Points tool for latitude and longitude to generate a spatial object from those XY fields, the latitude longitude fields. Now in this case, I'm going to disable the latitude longitude points because we're going to use another Create Points tool. So I'll just click the disable container, this kind of blue-black icon. Let's give myself a little bit more space on the canvas. Now here I've made a little container already for my British National Grid, my BNG points. And I want to drag in another Create Points tool. Now that's going to be in the Spatial tool palette. If you have that added to your favorites bar, as I do, just by clicking the little star icon in the top left, you'll be able to access that from your quick access kind of favorites bar, which shows up here. So we'll grab Create Points and we're going to drop this into the container that I've got. Obviously we need to configure this and connect some data to it. So let's go ahead and do this. I'm going to drag school location connector onto the anchor here, and I'm going to click the tool to open up the configuration window. Now you can see that we want to identify the X field and the Y field. This time we'll select easting as the X field and northing as the Y field. And reading down in the configuration window, these radio buttons are pointing us in the right direction. Our eastings and northings aren't latitude and longitude. They are projected floating points. So that third option, that's the one we want. So we'll put a click in this radio button, which then allows us to interact with this second window under here. WGS 84, that would be that long fields, but that's not what we want. So in order to change this, we'll just drift over here to this box with the 3 dots inside, and we're going to give that a click. And this next configuration window gives us the tools to select the projection that we want. Now notice that Alteryx is going to use the EPSG code this time rather than the SRID notification, but they're the same. So in the Find Projection, I can either type in the name of the projection, which I know to be British National Grid, and then I'll hit Find. And there we identify it as British National Grid with that OSGB 1936. Right underneath, you can see that I have that 27700 corresponding code. Right, if you knew exactly what you were looking for and where to look for it, you could just open up some of these drop-down arrows. That can be a little bit kind of convoluted to find something that you're not sure exactly where it is. So it's kind of cool. Use a little search bar. I can type the name in there. I can also type the code in there. And straight away, I'm pointed to that projection. So British National Grid is the one we want. So we're going to OK that. Perfect. Now we're going to pop a browse tool at the end of this Create Points. and see where we're at. And let's run this. All right. Now here in Alteryx, in its little map window, we've been able to plot points on a map. There's no base map here, so let's just prove that we're not messing around. This is London streets. You can see the M25 circling around, and we have the schools locations just using easting and northing. If we scroll across all the way over to the right-hand side, remember that that create points tool is spatially enabling our data set. So we've got the addition of a spatial geometry column, and in this case, the spatial object is a point. Now, if you're following along at home, do hit pause or rewind a little if you want some more time to run through this again, or you need some more time to put the tools into the canvas. If you're still with us, here we are making great progress. We're addressing alternative coordinate reference systems in both Tableau and in Alteryx. So this is great. And next on the agenda was an exploration of UK postcode data as another geographic identifier that isn't latitude or longitude. Obviously, for us folks here in the UK, this is pretty important. In later webinars in the Location Intelligence in Tableau series, we'll deal with postal systems and other identifiers that are outside the UK, US zip codes, for example. For now, we're going to stick with postcodes, and we'll explore them again in Tableau first, using the schools dataset. So let's drop back in to Tableau. I'm going to click my new worksheet here. Now, as I did for British National Grid, what I'm going to do is add in a clean version of the schools dataset without any latitude, longitude, and without the eastings and the northings. So we're just going to be left with postcode as an identifier. So again, I'm going to click the plus icon beside the cylinder for add new data. I want text file because this is also a CSV. And in this case, I've highlighted this as postcode only with the school location PC only file. I'm going to open that up. Alrighty. Now, notice that I have, in this case, already generated latitude and longitude fields in the measures part of the data pane. They're currently placeholders or flags where Tableau is saying, hey, look, I recognize one of your field names, and I think I can generate these locations for you when you bring that field into the view. If we look at the dimensions of the school address details, Tableau's basing that assumption on the postcode field. You can see that it's generated it, that blue globe. And if we right-click on postcode and scroll about halfway down to geographic role, you can see that postcode is one of the geographic identifiers that Tableau can plot using its internal reference sheet of latitude and longitude values. But watch what happens when we double-click postcode to try and bring that into the view. All right, nothing in the canvas other than a blank map. And over to the right-hand side, errors. We got 3,000 unknowns. Now I think that this should work. So I'm going to left-click on the unknown to interrogate this a bit more. I don't want to filter out the data because, well, I want it on a map. So I'm going to try and edit the locations to see what's going on. So I click on the first option. And in this edit locations configuration window, we can see that the top is correct. So the country region that we want, United Kingdom, that is right. We're in the UK. The zip code or the postcode field is called postcode in my data set. So that configuration is correct. But by clicking on the unrecognized message in Tableau, I can get a bit more of an idea of what's going on. So let me just click this drop down. Okay, now what's happening is that Tableau can only recognize the front end of this postcode. It's AB10, AL9, BR1, something known as the outward code. A brief interlude now follows on the joys of the UK postcode. So let's check out how they work. Now, postcodes are a way for the UK Postal Delivery Service, the Royal Mail, to code the more than 29 million deliverable addresses in the nation. And we encode to try to place the 29 million into more manageable groups for delivery. The postcode you're looking at here is the Information Lab's London office. Why not look us up? In this postcode and in all postcodes, we have an outward code and an inward code. And those two elements are split by a blank space, or they should be. Some datasets you may receive will have removed the space between the outward and inward code, and we'll talk a little more about that later. The outward code sorts the mail into the correct local area. The inward code directs the mail to the correct local delivery office. So as we read from left to right here, we're gradually adding more and more granularity, with the eventual full postcode able to direct a particular delivery person to a particular set of properties, representing a very small area in space. So small that we can accept it being represented in point form rather than as a polygon. But if we go back into Tableau and try and figure out what's going on here, again, Tableau is only recognizing the outward code, and it also isn't able to read that as part of the full postcode, even though we have that here in the data. And we can solve that element of the challenge quite simply by using a calculated field with a split function. So I'll go ahead here, click out of this, and I'm going to move up to the drop down at the top of the data pane. I'm going to select calculated field, and I'm going to call this outward code, try and spell that correctly, because that's what we're creating. And again, as I mentioned, we want the split function. So begin typing that. Let's hit enter to get some of the instructions for what we need to do. With the split function, we want the string, the field that we want to split. We then want to tell Tableau what delimiter, or what it needs to look for and where it's going to split. And then we also want the token number. So whether we're moving from the front, the end of the string, which delimiter we want to split on. In our case, there's only one space. So begin to type this in. The field that we want to split is postcode. The delimiter that we want is a space. So I'm going to open parentheses, hit the space bar, close my parentheses, another column, and again, like I've said, it's a single and only space. So I just want one. And we're going to OK this. Now over on the right hand side, we've got a calculated field called outward code, so that's worked, but it's not done yet because Tableau doesn't recognize the name of our field. It's not matching with any of those geographic roles. But all we need to do is tell Tableau that it has a geographic role by right-clicking and selecting postcode. So let's right-click, scroll down to geographic role, and hit postcode. And you'll see that the ABC has been replaced by the globe icon. Now let's clear what we've currently got, this postcode field that doesn't work. And let's double-click the outward code to see what we're left with. Okay, so we got a map. We got some stuff in a map where once there was no map. So that's progress. But we're still left with a bit of a quandary here because we've got a large loss of granularity in the data. If you look down to the bottom left, we're now at 301 locations where with the explicit latitude, longitude, or the British National Grid identifiers, they had us up at nearly 4,000 school locations. And this is a product of using the outward code. It refers to an area and not a specific location. And actually, Tableau knows this. If I change the mark type by hitting this drop down in the marks card, I'm going to change from automatic and I'm going to select map. And let me just give those borders a bit more definition. All right, we get an almost complete surface of outward code areas. Now I can aggregate the schools to form a thematic map by right-clicking the object ID, which I'm just going to make a discrete dimension. I'm going to drag that in to color, and I want a count of those things to create a basic thematic map. Now this is fine as an approach. It simplifies the view. It shows us the outward code areas that have the greatest and the least number of schools within them. If we want to have the full granularity of the data though, we've lost here by using postcode as an identifier. We can't see the precise density or the distribution of schools within each of those areas. We just can't do that with postcodes in Tableau. In the next episode, we'll be dealing explicitly with aggregation in detail, so I won't expand on aggregation and the issues involved in that just now. Instead, we'll focus on what we need to do with the postcode data to regain the granularity that we want. And a solution that we can enact ourselves is to supplement the data that we've got, to find a lookup table where we can use the full postcode to pull back the corresponding latitude and longitude of the data. Now, luckily in the UK, we have open access to a whole host of cool datasets, including the Office for National Statistics geoportal, which, when we download, we get a full list of UK postcodes, including the latitude longitude values for each postcode. Now, I've already downloaded the February 2020 dataset. So what I'll do now is establish a connection between my schools dataset and my postcode directory. Let's drop back into Tableau and do that. Now, to avoid any confusion or doubt about this method, I'm staying with the stripped back version of the schools dataset, where we only have postcode. So at the moment, remember, there really is no way to get the full granularity on the map at this point. But let's make it happen. I'm going to go down to the data source pane just on the left. And I'm going to set up a new connection to my ONS, my Office for National Statistics postcode directory CSV file. So I'll just hit add in the connection pane. I want text file because it's a CSV. And then here I have my ONS postcode directory folder, and I have my CSV file. I'm going to open. All right. Now all I need to do is relate these two data sets. And I want my join to run based on the postcode from the school's location, the postcode from the ONS file. You can see we have a lot of fields here. It's quite rich. The postcode is identified here by PCD. And I also want only the lat long postcodes that match with the schools. So I'm going to click a left join to do that. Now you can see that this successfully will run. We don't have any errors flagging up. But I also know that we sometimes get postcode data where the space between the outward and the inward code has been removed. Now, if that happens, it's going to cause a mismatch. It's going to cause our join to misfire. And to head that off at the pass, all I'm going to do is write a join calculation that removes any blanks if they exist, and then run the join again based on that calculation, like this. So I'm going to drift down to my school's data source. I'll hit the drop down, and I don't want any of the predefined fields. I want to create a join calculation. And it is based on my postcode. And all I want to do is find a function that is going to remove the spaces in this postcode. Now, actually in Tableau, that function exists, but it's going to be the replace function. So let's begin to type that in. And what we want to do is replace any spaces with nothing. So you can see on the right-hand side with the instructions, we're going to have the string that we want to work with, which is postcode. We're going to have a comma. The substring that we want to replace is the space. So I've opened parentheses, hit the space bar, close my parentheses. Another column, another aspect of this. We add the comma, and we want to include the replacement field. In our case, it's nothing. I just want to get rid of the space. So I'm just going to open and immediately close parentheses and then close off my brackets. And let's OK that. So that's a join calculation on the left. And I want to repeat that process for the right just to make sure that we're going to fire everything off correctly. So again, I'll create my join calculation. Only the one postcode field. Marvelous. And again, we want replace. The string that we're working with is postcode. We're going to replace any spaces with nothing. And then OK that. Again, this looks like it's running successfully. But here's the real test. Is it going to give us what we want? So let's drop into a new worksheet. Let's just tidy up some of these dimensions so we can expand the measures a little and just see what we want to have. All right. Now remember, the generated latitude, longitude fields, they're coming in from the postcode and the outward code, and we already know that they will not give us the granularity that we want. What we do want are the latitude, longitude, those explicitly generated fields from the ONS postcode directory. So let's see what happens when I double click latitude. We're also going to double click longitude. The suspense is building. Notice how this is taking a little bit of time to process because our postcode directory is a rich file, but it also contains information for all the postcodes in the UK. So it's got some churning to go on in the background. While I've been talking, we've got some stuff on a map. The next test is if we split this up with the object ID, are we going to get what we wanted originally? 3887 in the lower left, that's the number of marks that we want. Did it? We've done it. This has worked. Let's make that a little bit smaller. 3887 marks in the view. So here we are at the stage of using not only explicit latitude, longitude fields, not only Tableau's internal geocoding engine, but also supplementary data to get the results that we want to establish location for our data. And this approach is also something we can enact in Alteryx. And depending on the nature of our processing and the amount of data prep that we need to do, it might be better to leave Alteryx to do all this heavy lifting and database joins. You could see it took a little bit of time to get that onto the map. Perhaps if we've got a lot of processing to do, we're going to shift that over to Alteryx so that Tableau stays as nimble as possible in the actual visualization element of our process. And performance of our software tools is something that we'll keep coming back to in time. And we'll give you some examples of the sorts of questions that might be okay performance-wise for Tableau, and which also might be best left to Alteryx. But for now, let's get into Alteryx. And we're still going to be in our flow number 1, adding spatial data. And let me open that back up again. And if you need to pause the video to get this open, go ahead and do that. Just going to make myself a little more space, switch off this BNG box. And now we're interested in doing this join calculation with our postcode directory in Alteryx rather than Tableau. Now here you can see the inputs are the same. We've got a schools location dataset. We've got a GB postcode database, and we've got a join tool. Now notice the GB postcode database, it has the suffix YXDB rather than CSV. Now all that's happened here is I've done a little bit of secondary processing where I've taken the CSV, I've removed a few fields to make it a little bit lighter, and I've output it as an Alteryx database, a YXDB, just to stimulate a bit more efficiency when we're running through the processing. If we go back to our original workflow, again we have that join operation. And initially, as we did in Tableau, postcode matches with postcode, and that's fine. But again, the thing we need to guard against is the spaces between the outward code and the inward code that might cause our join to mismatch. Now watch how we're going to remedy this in Alteryx. What we need is a formula tool. If you've used formula tools a lot, they're going to be sitting in your favorites bar. If you haven't, the formula tool is going to be in this data prep tool palette. So we'll give that a click and we'll drag a formula tool into the view. I'm just going to put that into the middle of the stream, running from school locations to the left-hand anchor of my join, and I'll drop that in. And now I want to configure this. So it's good practice to make a new field rather than alter the existing field. So we'll hit this drop down by select column. I want to add a new column. And we're going to call this PC postcode full. And the syntax in Alteryx is very, very similar. In fact, I think it's actually identical to the Tableau syntax that we want. So again, it's that replace operation. The string that we want to replace is postcode. Sorry, the element in the string that we want to replace is in postcode. The target is a space or any space, and we want to replace that with nothing. And you can see in the preview bar that would get rid of any of the spaces that might have been between UB1 and 1LR. Before we do anything else, we're just going to drop into our join and just make sure that we have selected this new column that we've made to perform the join on. And all I'm going to do is click the filter tool, and I'm going to click this sort of label annotation option. I'm just going to get rid of a lot of this text so we have a bit more space in the workflow to see what we're doing. Here we go. All right, that gives me a little annotation that makes a bit more sense. Now, if you're following along at home, why don't you have a go at pausing the video and performing the same operation, the removal of the space operation, in the database, the postcode database that's coming in, remembering that the field that we're after here is the PCD field. So hit pause now if you'd like to do that at home. All right, hopefully you had a go at that. Let's go through how to do it. Again, we want the formula tool from the data prep tool palette. Let's drag that in and connect it up into the stream going to the right-hand side anchor. I like my workflows to be neat and tidy, so let's make those straight lines. And again, we have the configuration for our filter tool. So you want to create a new column by selecting this drop-down menu. Add new column. I'm just going to call it the same thing, PC full. And it is the same syntax that I used before. In the field PCD, the target that I want to replace, any spaces, so open parentheses and hit the space bar, and the replacement is nothing. So just double quotes, nothing in between. And like I've done before, I'll probably go back in there, hit this little label annotation, and again, just call this remove space. So I have a sort of short form of documentation going on for each tool. Hopefully you drop back in to the join tool to make sure the right-hand side was joining on the PC full rather than the PCD, because the PCD field still has spaces in it. Now let's run this and see what we get out at the end. Okay, 3889. And we know we had 3887 in Tableau. Now what we're going to do is just figure out what's going on, because now we have latitude, longitude from our postcode database. And what we're going to do is spatially enable that by using the create points tool again. And then we're going to browse the map just to see what's going on, why we have an extra couple of postcodes dropping in. So let's go ahead and go for the spatial tool palette and create points. Now again, if you want to try this out yourself at home, hit the pause button and we'll be waiting for you when you come back. All right, let's drag create points into the view. I'm just going to drop that into the stream between the join anchor and the browse tool. In this case, it's the latitude, longitude fields that we want. They've come in from our GB postcode database. So they are lat long. That's absolutely fine. We don't need to make any changes. We've got a browse tool in at the end, and that's going to let us see the spatial object that we've created from that latitude, longitude. So again, let's run and see what's going on. Let's hit the browse tool. Let's go to map. You can see already what's happened here. Let's put some streets in the background. All right. Now we've got this little 2-point addition to the data. It's coming in, it joins because it has a valid postcode, but by latitude, longitude, it doesn't look like it should be in our London schools data. And this is actually quite a handy data prep cleansing exercise that we can use to generate and work on some new spatial skills. Because now we're gonna do the final thing that was on our agenda for today. We're going to create a type of spatial filter that will allow us to make selections in our data based purely on geographic location. So not whether we have similar names in fields or fields, postcode and postcode that join, purely based on whether we have shared locations in space. And because some of our work might require us to have access to postcode level data for individual households in particular regions or areas rather than nationally. And for that, we can still utilize our full postcode database, but we want a way to filter down to the particular area in question, whether that's Manchester or Brighton or the Southeast or London, the London borough of our choice. And so far in the postcode data, let's just interrogate this a little. We have a whole host of identifiers, postcodes, census output areas, CCGs, these kind of clinical NHS groupings. But none of them tell us which postcode is in the city of London. We don't have a regional identifier here, just codes. So we can't rely on a simple join to strip out what's in London. But there is a way around this. This is the cookie cutter operation that we're going to do because we know where London exists in space. And we also know where these postcodes are in space because we've used the latitude longitude to generate a spatial geometry. So the software will know where to put it in space. Once we have those two things, we can perform a cookie cutter operation using the geographic outline of London. Let's step back a bit, just figure out conceptually what's going on. Here, I've got a pretty abstract diagram. Left-hand side, I'm looking to plot Great Britain and Northern Irish postcodes. These triangles, Northern Ireland, and this triangle, the larger one representing Scotland and Wales and England. Each of the dots inside these triangles is representative of a postcode. And we've been able to plot those in their right position in space because we've used their latitude longitude to enable them spatially. So that's the first bit of the ingredient. The second bit is to have a London outline, a shape that represents London. And when that is spatially enabled, we'll be able to simply drop that in to its right location in space and use it to cut out only the postcodes or whatever the objects are in question that we want for London. So we drop the shape over the top of our postcode layer and just strip out what's left. And that's a kind of cookie cutter operation. So let's go back and look at it now in Alteryx. And what we want to do, actually, if you're following along at home, is we're going to have this new workflow. It's called number 3, and it's called generate LDN postcodes, generate London postcodes. So pause the video if you need to find that. Again, it's number 3, generate London postcodes, and that's in your participants folder. I'm going to click this, and let's get ready to go. All right, you'll see coming in, we have that database of Great British postcodes coming in rather than the CSV. Again, just that simple conversion operation to add a little bit of efficiency. If I click on that incoming object, I'll click metadata, a reminder of what we have coming in. Let's expand that a little. Postcode field, a range of census output areas, CCG, so clinical commissions, identifiers, also the latitude, longitude, and this little bonus, the rank for the index of multiple deprivation, which I'm going to leave in now because in later sessions that's going to prove quite useful. Now let's go ahead and take the step of enacting this spatially enabled, begin that again. We're going to take the step of spatially enabling the latitude longitude fields in this database. Added a create points tool. The X field is longitude, the Y field is latitude. We drop the tool in and that's ready to go. Now for now, we're going to disable that box because we want it to be there, but we don't always want to run this procedure in the background when we're off doing something else. So let me just click this blue-black button, and that's disabled for now, but we'll come back to it. And what we need to do as our little additional bit is to get our geographic outline for London. This top bit gets our spatially enabled postcodes. The second ingredient, our spatially enabled outline, again for London. Now we've actually got that. I've downloaded the spatial outlines from the London Datastore, which you can get access to just here. This link is in the description box. I've gone ahead and downloaded what you need, the statistical GIS boundaries of London, and that's also in your participant folder in the data sources section. So let's go ahead and together add that in. What we're going to need to do is have in the in-out tool palette an input data tool, which we'll drag in. And we're going to go ahead and navigate using this drop down. We want files. We're going to select the file And what we want is to navigate to data sources, which is in your participant folder. And we want, in this case, London ships. So we're going to double click on this. Now you can see that I have London Borough. I also have LSOA. Those are the bottom half of options here. So we have some different hierarchies for London. For now, we're just going to choose the London boroughs. Also notice that it's the SHP, the shape file, the .shp file type that's going to render the geometry on the screen in both Tableau and Alteryx. So that's the one that we select. And let's hit open. Now straight away what I'm going to do is drag a browse tool into the canvas and run this so we can get an idea of what we're looking at if you're not familiar with London. Let's add a base map in. So you can see coming in 33 records, 33 shapes, each of those shapes representing a borough of London. So this is great. Now if we're interested purely in London as a whole, so not individual boroughs, just the outline of Greater London, we can also get that. And it just involves a little bit of work in another tool in Alteryx. The logic here is just that we want to scrub out these internal borders, and we just want to leave ourselves with the overall outline of London. So effectively, we're summarizing what is coming in to make it a bit more simple. And the clue's in the name, as always. That's the tool we need. It's the Summarise tool. Now, if you've got that in your favorites, then you can choose that from the favorites bar. If you haven't, you'll find the Summarise tool from the Transform tool palette. So give that a click and then drag the Summarise tool down here into the canvas. Now, top to bottom, the configuration here. Let's do this slowly together. All of these fields, these are all the details line by line for these boroughs, the names of the boroughs. Let me just click this input anchor so you can see as I talk through this what's going on. The name of the borough, its code, the area in hectares, and the spatial object, all of those things. Now, because we want to simplify this, we're not interested in line by line what's going on. We're just interested in the spatial object and getting it from 33 boroughs to one outline. So I'm going to go ahead, click the spatial object. For the action, the summary action, I want to click add, and it's a spatial action that I want. In order to simplify and to summarize what's inside, I just want to combine everything into one. So that's the option that I pick. I'm going to go ahead and drag another browse tool in so you can see the difference in these two. And let's hit run. Just contrast that first off, the 33 boroughs, more granular. Once we've done the summarize, one outline, one polygon object, giving us the outline of London, no internal details, simplified. Perfect. Okay, we're doing well. We're doing well. If you need to pause and just make sense of what's going on, feel free to do that. Jump back in when you're ready. Because now we're at the stage where we have the two streams that we need from this simplified diagram. We have spatially enabled postcodes. We created points giving us a spatial object for the postcodes for Great Britain and Northern Ireland. We also have a London outline, simplified, and that is natively spatial. That was a shapefile, so it is also spatially enabled. It's ready to go. Now all we need to do is ask Alteryx to tell us where the locations from each stream match. So let's drop back into our working canvas and give myself a little bit more space. I'm going to delete this browse tool here because we don't really need this anymore. I'm going to move these portions down and open up my previously disabled box for my postcodes. If you missed how to do that, the short way is when the box is disabled, the previously kind of blue-black toggle goes off. To enable it, you just click that again. Blue-black enabled, click it, white-black disabled. So we'll enable that. Lovely. And now what we want to do. Again, Alteryx, tell us where these locations match. So that clue is in the name. That sets us up for the tool that we want to look at. It's in the spatial tool palette. So let's go ahead and click that. And it is the spatial match tool. If we read the top bit, this is what we want to do. Combine two data streams based on the relationship in space. All right, let me drag that into my canvas and start to hook things up. Now, I can think about these points coming in as my set of targets. So I'm going to connect that up to the targets anchor. And I want Alteryx to return me which of those points fall inside the universe of London. So my outline. I'm going to join that up to the universe side. Let's open this up a little bit more. Let's just drag the edge of that and configure the tool. A little bit more. Here we go. All right. Going from top to bottom, the spatial object field from the target side, that is the centroid coming in from the points that we made. So that is configured correctly. The universe that we're looking at, that is London. And this is what came out, that combine the spatial object, that is what's coming out as a result of the summarise operation. Notice that we have an embedded select in our spatial match tool, so we can get rid of any fields that we don't want. And in this case, I'm going to get rid of the universe spatial object. All I want to do is return the points that are only in London. I don't want to also have the outline of London in my results. So I've switched that off. Now in terms of this drop down just here, where target intersects universe, if we click that, we have a range of options here. Now the intersection one is the one that we want. In later episodes, we'll be talking about the different ways that we can set this up, but its intersection is the one that we want. Let's go ahead, stick a browse tool in here at the end, so that when we draw this, we'll get only the points from our postcode database that are in London. And we've defined that by an outline of London. So that's what we're hoping to see when we hit run. Again, do hit pause if you need to get yourself up to this stage. We're going to hit run on our workflow and see what we get. It's going to take a moment to run, remembering that our GB postcode is large. Here it is chugging away in the background. Almost there. Moment of truth, let's hit this browse tool. Let's give ourselves a base map. Again, 300,000 coming in. Remember, this is all the postcodes in London, not just the school's postcodes. Look at that. Look at that. Here we have made a selection from our original dataset of, 29, 30 million postcodes. We have made a selection out purely by spatial location, not by saying these two fields match in name, purely by geographic location. And what I'm going to do is delete everything here, and I'm going to run through that again. So if you need to see it again, here it comes. All right, remember the ingredients that we need: spatially enabled postcodes. We have a full database of GB postcodes with latitude, longitude, so they're spatially ready as our input. Then we use the create points tool to spatially enable that. So that's one element ticked off. Just disable this so it's not kind of churning through all those millions of postcodes as we're doing our geographic operations. We needed the London outline, and we have the boroughs, so we brought that in as a shapefile, but we don't want all the details of the boroughs, so we just scrub them out by summarizing what we have. So we've got the summary tool. We only want a single spatial object, a single polygon representing London, so you go for spatial object, use the drop down to click add, hit spatial, and hit combine, and that is going to generate for us a single spatial object. Now, the first time I did this, I left the output field name as it was, but I can rename this by double clicking. I'm going to call this London outline, because that is a little bit more meaningful, and it will be useful when we come to do the spatial match, which we're now ready to do. So we hit the toggle to enable our container again, and we want the spatial match tool. So let's go to the spatial tool palette, grab spatial match, and I want to see the points coming out that are in London. So I want the points to run across the top to target. Those are the ones that I want to see coming out. So that's all along the top line. The centroid, that's coming in from those postcodes. For the universe side, that's my defined universe of London. Let's hook that up to the universe anchor. Again, you can see the spatial object field. Now that's a little bit more useful because I've named that London outline. So this makes sense. Now also in this case, and this is going to help us to run a little bit more quickly through this, I'm going to turn off the London outline. I don't want that to come out at the end. I just want the points to come out in that location. And again, where target intersects universe, this is the option that I want. And I'm going to drop a browse tool in after the match. Now notice as I was configuring that, I had that exclamation mark to tell me that something had gone wrong. But actually, as I went through, nothing was wrong. I just needed to hook up the right connections. Everything was configured. My exclamation point went away. So we're now good to run this. And let's press run. Ticking through. Again, looks right, 300,000, moment of truth. Here we go. We'll leave the base map off this time and just let those render. Smashing. Again, all of the postcodes in London. So we might need this for individual household locations. All of those things, business locations. We've been able to select that off. using a spatial outline. Now, if you're following along at home, here's a little challenge for you. We're going to apply this geographic filter and this spatial match operation, not for the entire of London this time, but for a single borough of London rather than the entire city. And what I'd like us to do is to try to run that for the borough of Southwark. Now, take a look at what you've got coming in from the London shapefile. You have the names of the boroughs. Now think about what non-spatial tool you could use to siphon off a single borough from that incoming spatial file. Now if you're going to try this at home, the full workflow, hit pause and have a go, treat yourself, and then jump back in when you're ready, because we're about to do this now. All right, here we go. If we only want a particular borough rather than the entire of London, what we're going to do is get rid of our summary tool because that's not necessary anymore. We're going to exchange that for a filter tool. Instead of having all of the boroughs in London, we only want Southwark. So we're going to go up to our data preparation tool palette, hit filter. This is the tool we want. And we're going to drag this into the canvas. Now, we know, again, that our incoming shapefile has the name of the borough under the field name. So we're going to go for Southwark. Let's configure our filter. Select column. We want name. So give me the results when the name equals Southwark. And then what we're going to do is join the borough of Southwark, that shape, and its polygon up to the spatial match tool this time. So we're not looking at the whole of London anymore, we're only looking at Southwark. We're going to need to do a little bit of reconfiguration in the tool because we've changed that universe anchor. So let's click the tool. This exclamation mark this time is telling us something useful. Here, it's still reading the London outline, which we don't have anymore. We want the Southwark outline. That's a spatial object, the polygon. That's for Southwark. Everything else in our configuration for the spatial match, for the targets, are all fine. For the purposes of this demo, I'm going to get rid of actually everything coming in from the universe side because I don't need it. All I want is to return only those postcodes that are in Southwark. So if I click on the canvas, I'm going to see this red explanation point disappear. Marvelous. I'm going to run this, and in my map configuration window on the browse tool, I'm going to be looking for a much smaller selection of postcodes, and we'll add a base map into that. So let's hit run. Here we are, getting ready to go. You can see about 12,000 postcodes, so much less than 300,000. So we're thinking this has probably done what we wanted. Let's hit the browse tool and see if it's where we want it. Okay, looks good to me. Let's put a base map in so you know I'm not cheating. Marvelous. Now, for those of you who know London, you'll know that this is Southwark with that SE1 postcode. If you don't know London, you'll have to take my word for it. This is Southwark. If you got this, really well done. Round of applause for you. Now, at this stage, depending on what our initial question was, we'd be ready to use this data set, so our geographically filtered data set, in more analysis. If the output of our analysis was just to get these postcodes, we could then output this from Alteryx as a YXDB, a database file for use somewhere else, or we could output it as a shapefile if we want to plot these postcodes in our mapping software or in Tableau. For now though, we've established how we get stuff onto a map, going from spatially ready to spatially enabled in a variety of ways, from Tableau to Alteryx, with explicit latitude longitudes, with internal geocoding engines, and by supplementing our data. We've also got this legit spatial skill with the spatial match tool and the cookie cutter technique. So this has been a big session, and it's at this point that we've come to another natural break in the content. So we're going to end our session for today. Come back and join me next time when we'll take a look at how we deal with aggregating spatial point data, household locations, GP surgeries, postcodes to areas, aggregation to local administrative areas, for examples, or census output areas. Until then, keep exploring and feel free to reach out to us here at the Information Lab for solutions to your data challenges. To stay up to date with all our YouTube content, hit the bell icon to subscribe to our channel. Stay safe, and I'll see you all next time.